High pressure die casting, also known as HPDC or just PDC, is used to make unlimited volumes of components out of aluminium, zinc, tin, magnesium, copper and brass. PDC is also a very misunderstood process. Some people may believe that pressure die casting is just a matter of pouring molten metal into a die, waiting for it to cool, and then removing a finished metal part. Because of this simplistic view, you might be tempted to think that it can be done with relatively inexpensive prototype tooling. But that's not really the case. In this video, I want to give you an overview of what the PDC process looks like and then share with you 5 awesome tips to get the most out of this process. My name's Gordon Stiles and this is another pressing episode of Serious Engineering for Serious Engineers.
Serious Engineering.
So what exactly does the PDC process look like? To start off with, I want to draw a graphic picture in your mind of how unbelievably fast and furious and violent the PDC process is. In some ways, it has similarities with the loading and firing of a howitzer. So let's explore specifically how the process works for aluminium, for example. The aluminium will have been heated to over its melting temperature of 660 degrees centigrade, typically around 690 C. It is then manually or automatically dosed into the shot chamber, and then the process of injection begins. There are 4 stages of injection which are not discussed much online, but I think they are very important. So let's have a look at them now. Stage 1, the plunger moves forward slowly, closing off the chamber opening. Stage 2, the plunger moves forward at a very specific and relatively slow speed that forms a wave front in front of the liquid aluminium that laps all of the air from the shot chamber out into the cavity. So now you just have a shot chamber filled with aluminium. Now for the really violent part. Stage 3, boom! The plunger pushes the entire shot into the cavity in a matter of just between 25 and 70 milliseconds, and for some much larger dies it can be up to a few hundred milliseconds. But this is fast, it's violent, and if the die has not been designed correctly, the air coming out of the vents can sometimes be so hot and moving so fast that you get supersonic screaming jets of fire, and that's why the vents are usually made of carbide. And then finally, stage 4, is what we call the high pressure hold. This final stage is designed to make sure that the metal is pressed out into the tiniest reaches of the die, helps to backfill the material as it starts to crystallize and shrink in its slush phase, and helps to squash some of the entrained air that gets trapped into the melt flow during injection. Whew! So, in summary, close the opening, push the wave of aluminium forward, punch it in, and hold it in. Thank you, thank you, thank you, thank you. The key reason why the fill time is so short is that as soon as that molten aluminium touches the relatively cold die at around 150 to 200 C, it immediately freezes. To give you an idea, a die wall will increase in temperature to around 400 to 450 degrees centigrade in about 1 second as the heat is transferred from the aluminium into the die, and then needs a further 20 seconds to cool back down. Now that's violent. Say what? One more time. Stages 3 and 4 require a lot of speed and force respectively, so they are assisted by 2 pressurized gas assist hydraulic bottles called the accumulators. And if these bottles have been switched off to save money, which sometimes happens with unscrupulous casting houses, or are just not working, then you will get a lot of problems with your shot, including major porosity and short shots. So, in that violent context, let's get to our 5 top tips. Tip number 1, don't ask for prototype tooling for die casting. So, when I say to you that there is no such thing as a prototype PDC die, you may have already guessed what I'm about to say next. Soft steel PDC dies just don't work. Yes, you could probably get a few shots, maybe even a few hundred shots, but what's the point? It would be better to just get some sand or investment castings done, or maybe some CNC machine prototypes. So we typically only offer imported DIN 1.2344, aka H13 tool steel, hardened to between 43 and 47 Rockwell. They are in effect production dies. If you have a good quality steel and a great part design, coming to that bit shortly, you'll be able to get around 100,000 cycles out of a PDC die, and more if you use PVD coating on the surface. Tip number 2, fill in the big holes. Knowing now that the injection speed is so fast, the last thing you need is any obstruction in the die that stops the flow of the material. Every hole in a die casting is an obstruction in the die. As the material jets around these obstructions, it has to recombine on the other side, and this is really difficult to do without entraining air when the material is flowing so fast. Also, most PDC parts have to be CNC machined in some way in post-production anyhow. Usually, it would be cutting some ceiling faces that need to be flat, or drilling and tapping or boring some holes. So if you have some larger holes or openings in the die casting design that may be causing problems with entrainment, we'd strongly recommend filling those in for the casting operation and cutting them out during post-machining. Given how fast highly specialized CNC machines for the machining of die castings are nowadays, such as the Brother Speedio, it adds very little time to the post-machining operation. We can also make this adjustment after trialing the die because it's a matter of removing metal off the die. And of course, as with plastic injection molding, we ask that you keep your wall thicknesses relatively consistent across the entire part. But that said, PDC is a lot more tolerant of wall thickness variation, but there are limits. Typical wall thicknesses would be from 2mm to 3mm, but can be as thick as 8mm, but this is not advisable. One thing I also recommend is being like water, my friend. Imagine you are the liquid aluminium flowing through the casting, becoming the die. Always take the shortest route. Whoa! Tip number 3, allow generous draft angles. The classic advice for draft angles on a pressure die casting is 2 degrees each side for both cores and cavities. Now please remember, 2 degrees of draft angle means minimum of 2 degrees of draft angle, and we strongly recommend that wherever you can, you go more than 2 degrees. 5 degrees would be perfect in most circumstances. Please don't listen to the people who say that you can get away with less draft angle on cavities. In some cases it is true, kind of, but in many cases it just doesn't work. I could do a whole video on why that is the case. And here is a bonus pet peeve. Please never design your product without draft angles and then ask your die maker to put them in for you. This is complete nonsense. I know it used to be a thing many decades ago, but since the introduction of 3D CAD, it is no longer acceptable practice in the real world. You must design your product with between 2 and 5 degrees draft angle per side from the very outset. Tip number 4, add 3 leveling pads to your design. Once the part has been cast, you will probably be wanting to do some post-machining. When you're designing your part, you should consult with your supplier to add 3 leveling pads on the back side of your casting that will be used to rest the part in the fixture before clamping on the opposite side of those pads. Also, make sure that you reference these pad faces in your GD&T. This ensures that the casting is held in the most efficient way, doesn't twist the part during clamping, and ensures that all of the GD&T makes sense. Tip number 5, use common aluminium alloys for PDC. Almost all technical aluminium die casting is done using just 2 closely related alloys. ADC10 and its equivalent A380 have between 7.5 and 9.5% silicon, and this alloy is one of the most popular and widely used throughout industry. Their cousins are ADC12 and its equivalent A383, which have between 9.5 and 11.5% silicon. So they're very similar, offer the optimum vacuum bubble to strength ratio, but offer slightly better filling characteristics and resistance to hot cracking. In the US, ADC12 is pretty much the go-to for almost all applications. And by the way, you can watch my next video which explains all about how silicon dramatically reduces porosity in PDC castings. Bonus tip, use a trimming die. Always insist that your supplier uses a trimming die to cut the overflows off your part. Otherwise, he might be hitting them with a big ass hammer and deforming your freshly minted casting. An alternative for low quantity casting is to CNC machine the overflows and gates off the part. Well, that's all we have time for today. Hope you enjoyed my theatrical performance and that you will be voting for me at the next Oscars. Like, subscribe and share, or I'll give you such a slap. Vote below if you were thinking Davey 504, Will Smith, Amber Heard, or was it Johnny Depp, or even a classic, or Bruce Lee. So many choices these days. And don't forget, we are the people that do serious engineering for serious engineers.
Serious engineering.